Okay, it's time for another physics exam, final exam. This is my physics for algebra-based physics course, the second semester, where it focuses on electricity and magnetism. I'm going to work through the problems. I'm going to do each one as a separate video, and I'll put them in a playlist. And I just want you to know that I haven't looked at this test in a while, so I did make these questions, but I don't remember. So me looking at this test will be more realistic. Do you like that? Okay, and then also I included this equation sheet. I don't really want to go over these things, but these are the kind of things you should know. And the constants, I would never have you memorize those, but that's just me. Some faculty do think that you should memorize those, and I respect their ideas, even if I don't agree with them. Okay, let's get started. Two charges, Q1 and Q2, and they have the following positions. So let's just a little sketch here. We have a -5 at the origin, -5 nanocoulomb, I'll put -5. And then 4 nanocoulombs over here at 0.4 meters, and this is 4 nanocoulombs. Find the vector electric force on an electron at 0.3 meters. Wait, this is on, I'm sorry. That's in the y direction. So it's up here. That's my 4. And then here's my electron over here. So this is 0.4 meters high, and this is 0.3 meters. Okay, so I can go ahead and put an electron there, and I'll just draw the better picture right here. So here's my -5 nanocoulomb charge. Here's my 4 nanocoulomb charge. And then here's my electron. And in order to find the net electric force, I'm going to find the electric force due to this one plus electric force due to that one. Let's call this one 1 and let's call that 2. So this is a negative charge and a negative charge. So F1 is going to be this way. And then F2 is going to be at an angle down like this. No, it's going to be up at an angle like that because that's positive and that's negative. So this is F2. Okay, so this isn't trivial because of this one at an angle, but we're just going to have to do it. So let's just find F1 first. Now I'm going to take a shortcut here so that I can spend more time on F2. So the force between two particles, F, is going to be K Q1 Q2 over R squared times R hat. Okay, where R hat is a vector pointing from the point to in between the 2 points, the R vector. So R hat would be the vector R divided by the magnitude of the vector R. Now, in the case of F1, that's pretty easy. Which way is this force going to be pointing? It's going to be pointing in the x direction. So for the F1, it's going to be K times Q1, which is -5 times 10 to the -9th coulombs, times the charge of an electron, -1.6 times 10 to the -19th coulombs, over the distance squared. Now, in this case, R is the vector from here to there, and that's 0.3 meters. So I'm just going to put 0.3 meters squared, and then my unit vector is going to be 1, 0, 0. I can do that by inspection. I know it's in the x direction. Okay, so I know the value for this. Let's just go ahead and get this as a vector so we can move on. So I'm going to go ahead and put this in. I'm going to drop that. K is 9 times 10 to the 9th. Be very careful with your scientific notation here. Enter. So now I have these two. I'm going to have a negative and a negative. I'm just going to make them both positive if that's okay with you. So I have 5 times 10 to the -9th times. Then I have 1.6 times 10 to the -19th, change sign, times. And then I need to divide by 0.3 squared divided by. And so I get 8 times 10 to the -17th times the vector 1, 0, 0. And this will be newtons because it's a force. Okay, now the next force is significantly more difficult. I'll put it right here. Okay, so F2, I need to first find this vector. You can't see it because I moved my thing up. I need to find this vector R. So if this is the vector, let's call this R2, and this RE. So R2 is the vector 0.40 meters. RE is the vector 0, 0.300. So R is going to be equal to RE minus R2, right? It's the final position's the electron, the initial position's up here. So I'll take final minus initial, and I get that vector. So that's pretty easy to do because I have, it's going to be 0.3 minus 0. 0 minus 0.4 is going to be negative 0.4, and then 0. Now I need to find the magnitude. So the magnitude of this vector is going to be the square root of 0.3 squared plus 0.4 squared. It's negative, but you're squaring it, so it doesn't matter, plus 0 squared. And I can take the square root, but I actually don't care. I guess I do care. Okay, so that's going to be, let's go ahead and find that. So I'm going to use my calculator again. So let's just drop that. So I get 0.3 enter squared, 0.4 enter squared, add them together, take the square root. I get 0.5 meters. Now, you could probably figure that out. It's a 3, 4, 5 triangle, so I did make this a little bit easier. Now I want to find r hat. R hat is going to be equal to the vector r, right there, 0.3, negative 0.4, 0, divided by 0.5. So I can just take 0.3 divided by 0.5, and I get 0.6. And then I can take negative 0.4 divided by 0.5, and I get 0.8. Negative. That's my unit vector. Okay, so now I do need a new sheet of paper. I'm ready to calculate F2. So F2 is going to be actually, let's just write it out. So F2 is K times Q1, which was, or Q2, 4 nanocoulombs. So it's going to be 4 times 10 to the negative 9th, times the charge of an electron, which is negative 1.6 times 10 to the negative 19th. So you see here, these negative signs do matter. My unit vector was 0.6 negative 0.8. And then I need to divide by the magnitude of that squared, which was 0.5 squared, because that was my magnitude. Okay, so I'm going to put all of this in. I'm going to take all of this and multiply it together and then I'll have that times the unit vector. So let's first do this part. So I get K is 9 times 10 to the 9th, 4 times 10 to the negative 9th, and I'll go ahead and do 1.6 negative times 10 to the negative 19th times, and then 0.5 squared divided by. So I get negative 2.3 times 10 to the negative 17th times 0.6 negative 0.80. So now let's multiply this out into the vector so I get just a vector answer. So I'm going to take this times 0.6, and I get negative 1.38 times 10 to the negative 17th. And then I do the same thing this times that. I get 2.3 times 10 to the negative 17th. The signs are going to, it's going to be positive. Enter. And then 0.8 times. And I get 1.84 times 10 to the negative 17th. 0 newtons. So now I have two forces. So F total is going to be F1 plus F2. So that's going to be equal to this. Let me write up here F1. I already had it. It's this 8 times 10 to the negative 17th. 8 times 10 to the negative 17th. 0, 0. So all I need to do is add these two components together, and then 0 plus that and 0 plus that. So that's pretty easy. So I just need to do this one right here. So I'm going to say, I already have, no I don't. So I'm going to say 8 times 10 to the negative 17th. And then I'm going to say 1.38 change sign, exponent, negative 17th plus. And I get my answer of 6.62 times 10 to the negative 17th Then I have this plus 0 is 1.84 times 10 to the negative 17th. And then I have the 0 plus 0. Let me put that in the calculator. 0 enter, 0 plus is 0. I'm just having fun here, okay? Newtons. And that's my final answer. There you go. So, I mean, this was a tricky problem. I mean, it was tricky and just said it was work, right? Because you can find these two forces, that's not too hard, but then you have to write F2 as a vector. And since it's not in just the X or Y direction, it makes it a little bit more complicated. And I admit that you kind of have to know what you're doing, but, you know, I gave everyone the option to do only 4 of the following 5 problems, which you can't see. So they could have dropped this one. Okay, moving on to the next problem in the next video.